Hi, let's see the solution of the question that is asked in the second internal examination. Here you have asked the question number 1A, which is of 1 mark. Resistance and inductance is given to you. The voltage is also given to you. You need to find the current. Now, current is equals to V by Z. To get the value of Z, you must know what is R and J omega L. So resistance is 1 ohm, whereas j omega L, that is omega is 2 pi f and L is here 0.01. Together it is omega into L and multiply with j. So the lower term is a complex number and in a rectangular form. The upper one is in the polar form. Convert the lower term in the polar form. Now you have got the ratio of these two, which is giving 30.35. This is the value of the current, the magnitude of the current. And the angle is 30 minus 72.335, that is minus 42.335. So you get the answer of current, its magnitude and also its polar form, angular position. If you would have been asked to draw the phasor, suppose this is x-axis and y-axis, the voltage is drawn at an angle of 30 degree from the zero-axis. And the current, which is minus 42, it is drawn over here, minus 42. This angle is minus 42.335. Overall, the current is lagging the voltage by an angle of 72.335. Next, the value of Z1 is given, Z2 is given, and it is said that both are in series. If they are in series, it is actually two coils, one Z1, another Z2 are in series. So obviously they are to be added. So the impedance of the Z1 and impedance of Z2 must be added. So when we add two complex number, you get a real number addition, that is 10, and the complex number addition, that is minus j6. Now this is in polar form. You have to convert that into rectangular form. So root over of 10 square plus 6 square will give you 11.662, and 10 inverse of minus 6 by 10 will give you the angle of 30 minus 30.96. Next is asked which loss is constant. The iron loss, which is depending on the hysteresis and eddy current loss, which again depend on the supply voltage. If the supply voltage is constant, the iron loss remains constant. In the question 2, you have till now you have discussed our 1 mark question. Now here you have 4 marks question. The question 2, the voltage is given 100 sine omega t. Frequency is 50 Hz. And the resistance is 3 ohm. Inductance is 0.0106 Henry. To get the value of Z, you need to know the R and J omega L. Substitute the value of L, multiply with F pi and 2. You will get 3 plus J 3.33. Find out the polar form, convert this from the rectangular to polar form. You will get this answer 4.4821, and the angle is 10 inverse of 3.33 divided by 3, that will come as 47.98. Now once you get the value of Z, since you are here, V is equal to 100, this 100 is nothing but Vm. that is maximum value. So from that you can get what is the Im. So Vm is given in polar form. Z is also obtained through in a polar form. So ratio of these two will give you the magnitude in polar form 22.31, and the subtraction of these two angles will give you the angle minus 47.98. Once you know the value of Imax, next is the question asked, find out the RMS value. RMS value is Imax by root 2. You got the answer 15.776 ampere. Phase angle is this angle is the same as this. Phase angle will be same, and this is 47.98. Since it is negative, it is lagging from the voltage, because voltage is with angle 0 degree and the current is coming with minus 47. So net difference is 47.98 lagging. The negative says it is lagging. Now what is the current? Current is the Imax value. Already we have obtained the Imax value. This one is this. And angle what we get here minus 47 need to be written here. So this is the instantaneous value of the current. We can write like this. Now power dissipated in the circuit can be given as P is equal to VI star or VI cos phi. So here V is the RMS value of the voltage, current is the RMS value of the current, cos of angle between them. So RMS value is the peak value by root 2, and again the I is the peak value by root 2, and a cos of angle between them, that comes out to be 746.7 watt. And the power factor is obviously cos of 47.98, which comes out to be 0.669 lagging. Next is the answer 3. It is being asked that the series RLC circuit is there, where R is of 5, L is of 50 millihenry, and C is of 40 picofarad. Now C is given in terms of pico, 10 to the power minus 12. Writing the solution, first find out the value of Xc, then find out the value of XL, then find out the value of R. R is already given. Then from this, if you combine this, you get the value of Z. Z is summation of R, XL, JXL and minus JXC. Once you combine it, obviously you will get a very high value. On the right, imaginary term is very high compared to the real number. You got values like this, and this is in polar form a very high value with a negative minus 90. So getting a value of current, obviously the current will be a very small quantity, and Z is in the denominator, so minus 90 will be now plus 90 for the current. So once you get the current, now we are ready to answer all the question. Impedance triangle is asked. So obviously we know in the X we have got R. In Y we have got XL minus XC, J times of subtraction of them. So you can get the real values placed over here and draw the impedance triangle. So and Z is the square root of R square plus XL minus XC square. Okay, so this is a base, this is a perpendicular, and this is the hypotenuse. Impedance in the complex form, impedance is this what we got here. The R is very small, R is 5, very small comparison to the XL minus XC. Since XC is very high, we get a negative number over here. We get a negative number and we get this high value. Phase angle between the voltage and current, obviously the phase angle is 90 degree. How do you know? Here it is. Phase angle is 90 degree. If it is asked lead or lag, so obviously it's a capacitive, so it is leading. In answer 4, You have a three-phase AC circuit is given where VL is 440 volt 50 Hz. It's a star connected load. Now these are the data of per phase in a star connection. That means if a star connection is there, so there is an inductor, resistor and capacitor in one line. Then it is connected with another capacitor, inductor and resistor, and then it is connected with another capacitor, resistor and inductor in series. So these three are the connected in three places, R, Y, V. So that's why it is connection. Now the per phase value is given for all. So convert that R, L and C into R, XL, here this is XL, and convert that into XC. XL is equal to 2 pi F into L, XC is equal to 1 by 2 pi F into C. After you substitute, get the value of Z, subtract these two values, you got the value of ZPH per phase. That means in each phase, what is the value of Z, get in a polar form. So looking at it, it seems that this is an inductive load, and overall it's an inductive load because here the negative term is my 15.91 and the positive term is 31.41. So overall it is an inductive load. Now line voltage from the question only you can get this answer, 440 volts. Phase voltage, it is a star connection load. Obviously the phase voltage will be the root 3 times of the line voltage, 1 by root 3 times of line voltage. You got 254.03. Phase current I phase will be equals to the phase voltage by phase current. The suggestion is that you convert everything in terms of the phase, like Z phase, V phase, then you get the phase current easily. Just divide by V phase by I phase and you get the I phase current as well as its angle. Since the star connection, so the phase current and the line current must be equal. Because it's a star connection, so here you have got a star connection, so all the phase current and the line current both will be equal. This is the phase current which is going through the phase and the line current which is going through the line, and you find that these two are same. Now the power factor is obviously the cos of this, so cos of this you will get 0.955. Since the negative, the current angle here is negative compared to the voltage, that's why it is lagging. So current negative compared to the voltage, then only. Power consumed is root 3 VL IL cos phi, or 3 times of V phase I phase cos phi. Now we have the V phase voltage, current phase current and cos of phi. We get here the power consumption in a 3-phase load, which is 3 times of V phase I phase cos phi. Thank you very much.